Welcome to the series lecture on instrumentation and transducers. So in this video we are going to discuss with respect to indicators and display devices. In the case of indicators, we need to talk about a PMMC, we need to talk about a moving iron coil, we need to talk about EMMC. And in the case of display devices, we need to talk about LEDs and LCDs. These two topics are important. Apart from this, we need to talk about the printers also. In the previous year exams, they have talked about printers, classification of printers. In that, they have spoken with respect to DPI. If I am speaking with respect to the classification of printer, the main thing is a drum printer, a laser printer, inkjet printer. These things are important. Lots of questions they have asked from this topic. So in the previous video, we have already discussed with respect to the static characteristics. That is, what do you mean by accuracy? What do you mean by resolution? What do you mean by precision? What is the expected value? And how we are going to define the error, definition of error, static error and dynamic error you will be having. Static error is not a function of time, whereas dynamic error is a function of time. Apart from that, you will be having several classifications of error. All those things we have discussed in the previous video. Also, error can be positive, negative, and it can be even zero also. What do you mean by sensitivity? How sensitivity and resolution will affect the system or will affect the measuring unit, or based on these things you are going to decide the voltmeter and ammeter or any meter of your choice. In the case of error, if I am speaking, you can classify it as a gross error, a systematic error, as well as a random error or residual error. And in the case of systematic error, you will be having further classification as instrumental error, environmental error, observational error. In the previous video, I have discussed with respect to the loading effect. In order to reduce it, we are going to make use of clamp on ammeter. Very, very important. Clamp on ammeter. Misuse of instrument also I have discussed. If you are using voltmeter instead of ammeter, or if you are using ammeter instead of voltmeter, just a simple example, right? So these things are misuse of instrument. And look at the things. The static error and dynamic error, these two things are very, very important. And the dynamic characteristics of error is also important. So we have discussed the classification of error, and we have discussed the types of error, nothing but the classification. Also definition of error we have discussed. Now we need to talk about the source of error. So in the sources of error, insufficient knowledge, poor design, change in process parameters, poor maintenance, and error caused by the person while handling the instrument or the equipment, and certain design limitations will be there. So these things are the sources of error. And in the case of dynamic characteristics of error, we have discussed, we will be having four things that need to be, or four parameters that need to be emphasized. One is the speed of response, in turn related to lag. Fidelity is one of the parameter, and dynamic error is very, very important. So these four characteristics, or these four dynamic characteristics of error, we have discussed in the previous video. So in this video, we shall discuss with respect to analog instruments. Now look at the things, how we are going to classify the analog instruments. Analog instruments are classified into integrating type, recording type, and indicating type. In the case of indicating type, it is going to come up with the value. Say suppose in the case of analog instruments, you will be having a needle which will be showing a deflection, or which will be indicating the value. Examples are your permanent magnet moving coil and a moving iron. So these things are the example for indicating type. In the case of recording type, you will be having seismograph, ECG, EEG. In this, a pen is attached on to a paper, and it will be plotting. So based on the plot, they are going to come up with the conclusion, right? This seismograph is used to measure the earthquake, right? You are going to make use of a Richter scale, and then you are going to analyze. Right. Next, ECG, EEG, you will be getting a plot kind of thing that we will not be in a position to understand, but the doctor, they will come to know what is the actual scenario. So these things come under recording type. And next one will be your integrating type, nothing but we are going to use in energy meter. Say suppose as of now the energy meter reading is 5000. In the next month, if say suppose if its reading is 5012, nothing but what, 12 units of energy you are consumed. 12 units of energy you are consumed. In the subsequent month, say suppose it is 5050. Nothing but what you have consumed 38 units. So you have to pay only for this 38 units. You have to pay only for 38 units. Very, very important. So this is the real power what you have consumed. So you are not going to pay for reactive power and all. You're going to pay bill only for real power. What do you mean by real power, reactive power? In the case of networks, I am going to discuss. There are three main torques. One is a deflecting torque, control torque, and damping torque. So now say suppose needle is at 0. If it is say suppose if it wants to show a reading up to, say suppose if it is 0 and this is 5. So this is somewhere like 2.5. The needle is somewhere over here. Initially it is at 0. Now it has to deflect up to, say suppose up to 2.5 it has to deflect. So now it is moving, and the job of the needle to move is with the deflecting torque, and the control torque should oppose at 2.5. Maximum and equal opposition will be at 2.5. Nothing but the needle should stop at 2.5. That reverse force is given by this control torque, and the deflection force is given by this deflecting torque. Right? Needle movement is taken care by deflecting torque. At what point you have to stop, that is given by control torque. Now one force is in from left to right, another force is from right to left. Now what happens is a damping occurs. What kind of damping you are going to face? Under damping, undamped, over damped, critical damped. So that is taken care by damping torque. Needle initially starts moving from 0 to 2.5, and then it will deflect and it has to stop. How fast you are going to stop it is very, very important. Most of the cases we are going for under damping only. Next, in the case of control torque, you will be having a spring control mechanism and you will be having gravity control mechanism. As the name indicates, in the case of gravity control mechanism, nothing but what? Orientation is fixed. And it should be with respect to your gravity. So in the case of spring control mechanism, either you can place in vertical or horizontal, whatever or however you want to place, no problem. Here the scale that is going to exhibit is a linear scale, but in the case of gravity control mechanism, the scale that is going to exhibit is a non-linear scale. Reading non-linear scale value is a bit difficult. But linear scale, you can predict the further value so easily. And placing or orientation, you can place either vertically or horizontally in the case of spring control mechanism, but in the case of gravity control mechanism, no, only one particular direction you have designed, means that particular direction only you have to follow. Maintenance or drawback: in the case of spring control mechanism, temperature variations will be there and aging effects will be there. Say suppose if I am considering a spring, compression and retardation, compression and expansion, this creates a tensile strength inside it, and its effectiveness will get reduced. But in the case of gravity control mechanism, it is not the scenario. Very, very important. In the case of spring control mechanism and gravity control mechanism, you will be having PMMC and you will be having MI. What is the scale it is going to exhibit? Very, very important. In the case of PMMC, that too in spring control mechanism, the scale will be linear. In other cases it will be non-linear. MI, it will be completely non-linear. Very, very important. Right? Now, what do you mean by PMMC, MI, each and everything we shall discuss in the further slides. As of now, see, you have to stop the needle or you have to stop the movement. You can blow air, or say suppose in the case of bike, you will be having that piston effect. That piston effect is with respect to oil, right? That is something like a fluid kind of thing you can consider. Here the friction is given by that viscous, nothing but the fluid, because of the viscosity. And in the case of eddy current damping, you are going to make use of the eddy currents, nothing but opposite way you are trying to flow the current. In the case of construction, in the case of air friction damping, it is simple to construct. But in the case of fluid friction damping, bit complexity is included, but in the case of eddy current damping, more complex is there. This difference is very, very important. In most of the cases, he has tried to ask for order of effectiveness, nothing but which one is better he is asking. Maintenance wise, you should know mounted, how you can mount it. In the case of fluid friction damping, say suppose you have designed for vertically, Horizontally you can't place it. Why? The fluid may come out, or there will be a chance of leakage. Or protecting the liquid is very important. One example, if you want, say suppose a bike, anyway it will be in the standing position. You try to tilt it. You keep it for 1 month. Many things will get stuck. Right? There will be an oil leakage. There will be a spillage in piston rings and all. Right? In the case of frictional part, if I am speaking, air friction damping, it is going to offer less. In the case of eddy current damping, it will be more. Right? But the frictional part, in the case of air friction damping, it is air. In the case of eddy current damping, it is current, reverse current. In the case of fluid friction damping, it is liquid or viscous. Order of effectiveness I have already discussed. Now let us try to analyze a PMMC. You will be having an horseshoe magnet which is at the sides, but here you will be having that needle movement. Here the actual movement part is a spring. Spring is the one which is going to carry the current. When there is a cut in the spring, no any current will flow. At that time the pointer will be at a minimum position only. Now what sort of question they will be asking? What is the magnetic flux density that is being produced? 0.121 Weber per meter square. Now what is that horseshoe magnet that is made up of? All aluminum, nickel, cobalt. Now here the spring is made up of phosphor, bronze. Here the spring is going to carry the current. But in the case of MI, there is no any spring that is going to carry current. Right? Now pointer is made up of aluminum. Jewel bearings will be there over here, which is used to reduce the friction. And how we are going to define the torque? Torque is defined as force into perpendicular distance. I have discussed in the case of PMMC, you will be having a linear scale. How you will be getting a linear scale means, see, this damping dot TD is proportional to BNAI, proportional to current, nothing but what it is, a linear scale. TD is proportional to I. So the maximum current or voltage that you can measure with the help of PMMC is a very low value, that is in the order of 20 milliamperes to 100 millivolt. Very low value. On passing the high currents, what is the problem you are facing means the frictional error is going to increase and sensitivity is going to decrease. So this is the problem you are going to face when you try to measure a high value of current or high value of voltage. The spring is the one which is going to get damaged so easily. Right? So this is all about a PMMC. They are going to call by the name a d'Arsonval type galvanometer. Till now we have discussed with respect to PMMC. Now we can get into moving iron. In the case of moving iron, you will be having two variants. One is attractive type and the second one is repulsion type. In the case of attraction type and repulsion type, two things are very important. How the current is getting into or how the current is getting out is very important. Based on that, you are going to classify it as a attraction type or repulsion type. In exams, they try to compare with respect to PMMC, MI and EMMC. Now the accuracy of the measuring unit or the instrument is limited. What is the scale they are going to use is a non-linear scale. In the case of PMMC, you are going to make use of linear scale. There spring is the one which is going to carry current. Here you will not be having any spring kind of thing. Spring is the one which is going to carry a current, so it is going to deflect. If you want to measure voltage, current multiplied by resistance will be the voltage. At low current values, the peak to peak of the AC, that is going to produce a greater displacement per unit current than the average value, resulting in an AC reading that may be appreciably higher than the equivalent DC reading at the lower end of the scale. Moving iron coil is meant for measurement of high frequency. Low frequency, it is not in the position to measure. This one important thing or one important parameter you try to remember. If you want to increase the range of a voltmeter or an ammeter, we are going to make use of the swamping resistors that is made up of manganese. Usually, like 5 years down the line, you just refer to the previous year question papers. They were asking these kind of questions. What was the resistance that is made up of? and what are the resistance that we are going to use. Simple thing, in the case of a voltmeter, one extra resistor you try to connect in a series, that itself will be acting like an external resistance, right? Thereby the voltmeter range will be increased. Now what is the usual range? See, initially it says suppose the resistance is Rs. The swamping resistance should be 20 to 30 times of Rs. 20 to 30 times of Rs. Very, very important. You refer to the MCQs. There I have tried to ask, in the case of voltmeter design, the swamping resistors should be connected in series. But in the case of ammeter range or ammeter design, we are going to connect in parallel with the meter. Very, very important. A range increases. See, in this world, nothing is available at free of cost. One you want means another you have to sacrifice. In this scenario, if you want an increase in range, there will be a decrease in sensitivity. If you want an increase in range, you will be getting a sensitivity which is a lower value. Very, very important. So now we have tried to discuss with respect to PMMC and MI. Now let us try to emphasize with respect to EMMC. This EMMC is a combination of PMMC and MI. This EMMC can measure voltage, current. Not only these things, you can able to measure power, power factor, and even frequency also. Very, very important. Here you are going to make use of eddy currents. Now if you are not in a position to understand the theory, at least you try to remember this table. Very, very important. You can able to measure, in the case of PMMC you can able to measure the DC quantity, but in the case of MI you can able to measure both AC quantities as well as DC quantity. What do you mean by that? AC voltage current, DC voltage current, that's it. But in the case of this PMMC, you can able to measure DC voltage and DC current, that's it. In the case of EMMC, you can able to measure the voltage, current, power, power factor, frequency, right? This is with respect to AC. In terms of DC fan speaking, it will be voltage and current and power. The scale in the case of PMMC is a linear scale, so it is a BNAI. So TD, nothing but what? Damping torque is proportional to the current. But in the case of MI, TD is a half times of DL divided by d theta into I square. Very, very important. In the case of EMMC, it is I1, I2 into dm by d theta. Value it is going to read what? Average value or the DC value. But here it is going to read an RMS value. Very, very important. Damping used in the case of PMMC. Damping used in the case of PMMC, it is eddy current damping. In the case of MI, air friction damping. In the case of EMMC, again air friction damping. What is the value of B? B is very, very high in the case of PMMC, low in the case of EMMC. Torque is more in the case of PMMC. Weight is more in the case of PMMC. Why? Weight is more in the case of PMMC. Why? You are going to make use of an horseshoe magnet, which is very, very bulky, right? Torque to weight ratio is also more in the case of which one? PMMC. Sensitivity is more in the case of PMMC. Frictional error is more in the case of PMMC. Why? Because of the spring movement which is going to carry the current. And what is the value or what is the range of the current that you can able to measure in the case of PMMC is in the order of milli. But in the case of MI, it is in the order of hundreds. Very, very important. 2 wattmeter method is very, very important. I'm going to put a video on this. You please go through it. Now, if I am speaking with respect to a display unit, see, displays are used in order for convenience. Say suppose from far if you are seeing, if it is having a needle movement, you are not in a position to read the exact value. Why? Many sort of errors you will be having. One simple error is a parallax error. At what angle you are viewing it. Very, very important. Now, you will be having a CRT display, you will be having LED display, you will be having LCD display. Apart from that, you will be having several variants. But for exam point of view, let us go through LED display and LCD display. And in the case of CRT, anyway, in other subjects you are going to discuss with respect to the CRTs also. Now, here in the case of LCD display, how we are going to get the image is with the help of scattering. They can operate both in reflective as well as a transmittive configuration. They do not actively generate light and depend for their operation on ambient or backlighting. Right? Now, when compared to LED display, LCD displays are going to consume less power. Power dissipation will be less. Low cost will be there. A large area and low operating speed. But if you are speaking with respect to clarity point of view and pixels point of view, LED displays are very much better. And angle viewing point of view, LED displays are better. Now, what are the important features of a liquid crystal display? The electric field required to activate LCDs is typically of the order of 10 power 4 volt per centimeter. This much of huge value you are in need. Now, the power required is less. LCDs are very slow devices. They have a turn on time of a few milliseconds. This is very important. And turn off time will be tens of milliseconds. These things are very important. They can ask. But if I am speaking with respect to an LED, when compared to LCD, you know more about LED. This is a semiconductor PN junction diode which is capable of emitting electromagnetic radiation under forward bias. Now, the radiation emitted by an LEDs can be either in the visible spectrum or it can be even infrared region also. TV remote, AC remote, it will be in infrared region only, depending on type of the semiconductor that is used. Okay. LEDs are very fast devices having a turn on and a turn off time of less than 1 nanosecond. Try to remember these values. Very important. The low cost supply and current requirements of LEDs make them compatible with even other families also. Important. Now, different materials. This question they have asked n number of times. For LCD design and for LED design, what and all the doping concentrations you will be having, and what materials you can club and you can able to generate, and what kind of emission it is going to occur or obey. These kind of questions they will be asking. Different materials used for doping to give out different colors. See, a single LED can emit multiple colors based on the wavelength, right? Gallium arsenide red, gallium arsenide phosphide, it can emit a red or yellow, and similarly gallium phosphide, it can emit a red or green. See, in serial sets and all, you can able to see a single LED will be there, but it will be emitting multiple colors. Simple thing is what voltage you are going to provide. What voltage it is going to provide. Important. Now, based on the LED, you can design for 7-segment display. 7-segment display. Clarity here will not be there. Say suppose you want to display A, you will be displaying something like this. You want to display R, A or R, both are same only. So only we are not going to prefer LED this one 7-segment display. But for traffic signals and all, we are going to prefer this 7-segment display. Why? The numbering you can able to easily display, no any problem, and the range will be more. Two variants of design you can able to incorporate. One is a common anode configuration, second one is common cathode configuration. In the case of common anode configuration, all the anode terminals are shorted and it is given to the plus VCC. But in the case of common cathode configuration, all the cathode terminals are shorted and it is given to the least supply. The other ends that is left free is connected to a microcontroller. Based on the program, the value will be displayed. Very important. Few basic comparisons are given with respect to CRT display, LED display and LCD displays. Please go through it. Now, if I am speaking with respect to a printer, what actually you mean by printer means the hard copy that is being generated. Printers are used to generate a photocopy. Don't tell give me a Xerox of it. The actual thing is give a photocopy of this paper. Xerox is the company name. Character printers and graphic plotters are the two devices which is used to prepare a permanent or a hard copy record of a computer output. But here we try to talk about printers. The basic difference between printers and plotters is that the former are devices which purpose is to print letters, numbers and similar characters in a text readable form, while the latter print diagrams with continuous lines. In the case of this plotters, continuous lines you'll be getting, but here in the case of printers, you'll be having a letter display, you'll be having a number display, you'll be having a character displays. Right? The classification of printer, several versions are there, but way classification if I am making use or if I am bringing out, it is impact and non-impact printers. Very important. Fully formed character and a dot matrix printer, character at a time and a line at a time printer. What do you mean by this? Let us discuss. Now, in the case of impact and non-impact printers, you please go through the difference. Impact printers form characters on a paper by striking the paper with a print head and squeezing it in with an inked ribbon. In olden days, you will be having that ribbon, right? Tuck, 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 sound you will be getting more, right? That is an impact printer. But in the case of non-impact printer, without engaging with respect to the print mechanism, here the ink is sprayed. Here the ink is sprayed, right? From like a jet, right? So the ink is sprayed. Say suppose you want to come up with a character. So based on the shape, the ink is sprayed. But in the case of impact printer, it is something like a rubber thumb kind of thing. You will be putting a seal, right? Something like that. You will be having that A part that it is going to strike to the ribbon. There, A will be displayed. But in the case of non-impact printer, the ink is sprayed. Very important. Fully formed character and dot matrix printer. Character at a time and line at a time. What do you mean by this? Let me try to explain. In the case of dot matrix printer, see, you will be having a group of dots. It is going to form a letter, something like this. What's the size of letters you want? Based on this, you are going to come up with, or you are going to take a printer. 5 x 7, 9 x 7. So you want better clarity, you are going for 9 x 7. Size you want more, you have to upgrade with the printer. But in the case of inkjet and in the case of laserjet, connect to a computer, whatever the font you want, easily change in a computer, get the print of it. But in ribbon one, you will not be having the flexibility. Character at a time dot matrix printer, common speed of dot matrix printer is 50 to 200 CPS. Very important. Try to remember these values. But printer with a speed as high as 300 CPS are also available. Okay. The dot matrix printers of the characters are stored in EEPROM. Very important. Where it is stored and what is the significance of ROM and RAM in this, they try to emphasize. You please go through it. Non-impact printers causes a mark without directly touching a paper. They are therefore quite compared to impact printers. That's what I told. They cannot make carbon copies, however, as there is no force to impress the character to multiple carbon copies, NIDM printers are useful for printing single copies on a computer output, for recording the output or printing calculations and video displays, and for logging industrial data. Important. There are 4 types of NIDM printers: thermal, electrosensitive, electrostatic and inkjet printers. Nowadays they are going to prefer inkjet printer. So this is all about indicating types and display devices. Some of the MCQs I have displayed over here. You try to answer it and you try to comment in the comment section. If you are having further doubts and if you want to talk to us, please call on the number that is given below, that is 6301356984, or you can join to our group that will be given in the description. In the previous video, we tried to discuss with respect to the static characteristics and what do you mean by the error, what are the types of error, what are the sources of error, and how you're going to minimize it. All those things we have discussed. So friends, in this video we have discussed with respect to indicators and display devices. If you have followed with this lecture, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you. For test series, make use of craving gyan.com.